Okay, so if you don't remember where you were, all right. Bunch of things. Okay, first of all, these are clearly little beat up. They have, believe it or not, been updated but not the count size. These review books, notice it says do not write in the binder. Please don't. I try to reuse these each year. When we first made them, we had 150. I'm now scraping 85, and I make 20 or 30 new ones each year. It's irritating when you don't return them. Please return them. These are just old tests. They do not release multiple choice very often, and as far as I know, they don't release multiple choice anymore. So the ones in here, oh my goodness, 1998, a lovely year. I was not a teacher then. 2003, 2008, 2012. So I find it's best to study for the test with this rather than one of those Barron's books that says, okay, here's a chapter on L'Hopital's, here's a chapter on convergence tests. Because what's the answer to every question you get? Maybe I'll do L'Hopital's because that's the section I'm in. So this is like in its native habitat, all of the kinds of questions you could see in all the mix. Alice, take my book. And the format has changed. The multiple choice is all online now. I need to figure out what's going on with that. And try and get you guys some practice before. So, yeah. But time yourself with these, and when you hit the timer, stop, like legitimately stop, check your answers so that you can see, all right, pacing myself, I didn't get past question 15, how big a deal is that? Also look to see that in questions 1 to 10, you might get 7, 8, or 9 of those right, versus 11 to 20, you might get 4 or 5 right, and then maybe you didn't get to questions 21 to 28 or whatever. Like just so you have for yourself an understanding of pacing, and don't feel demoralized if you get, wow, I only got 15 out of 30. That's about an 89. That's a 4 plus. If you can get better than 50%, you probably got a 5. So, yeah, by the time we get to the AP exam, you'll be like, yeah, I got a 60. Yeah. And fourth quarter, which this is now fourth quarter, the majority of your tests are going to be one AP test cut into 5 pieces, and they are all on the AP curve. Unfortunately, chapter 9 and chapter 10 are not that, but the rest of your test things are curved. In the back of this, there are the free response questions for a number of years. And I don't recommend doing them all, but having a look at, the 6 problems look like this. Question 1 and 2 are all with calculator, and often it's a random and then something from chapter 10, usually, a vectors or polars kind of question. And then in 3 and 4, there's usually something that is fundamental theorem of calculus, and a rate in, rate out kind of question. Question 6 is always from chapter 9, and question 5 is also often a random. It could be the chapter 7 volume spinning around. It could be any kind of thing, but get a look at them and get a feel for what's coming. Like, questions 1, 2, 3, and 4, I haven't seen fundamental theorem of calculus yet. That's coming up. Anyway. So please don't write in these. Keep them till after the exam. Any questions? And if you don't want yours, which some people don't, I have exactly, or maybe one extra. So if you don't want it, by all means put it back. Okay, can you put them away if you want to keep them? And get out a notebook so we can start chapter 10. Spring break starts the 11th. We're cutting a day off color so that your chapter 10 test will fit before spring break. As far as I know, administration has chosen to not change this yet. The week we get back, they were like, oh, you AP teachers we had extended learning days in the past where they had 2 classes in a day that were like an hour and a half. And then a bunch of little, and then so that you can do a practice AP test or a longer lab experiment, something, in all 7 periods. Okay, so they chose to do that the week right after we come back from break. So the extended time blocks for a potential AP practice test, or like, the multiple choice test that you guys have to take without a calculator, those blocks for first and second period are Monday the 21st, the day we get back from break. That's not my choice, but I don't know that I can say, gee, thanks, could you guys do this a different day? So just a heads up, that might happen. And then I believe 3rd and 4th are on the 22nd, and it's not a great schedule, yay! So just letting you know what we're dealing with. Okay, today we got 3 quick ideas to get through. One is, do you guys remember parametrics? We did them a little bit in chapter 3, just yeah. We just did their first derivative. Roman, do you remember how to find dy dx if that's x of t and y of t?
Do dy dt, we then multiply by so dy dx.
Yeah, okay. So he said dy dt, which dy dt, derivative of sine t is cosine t. Dx dt, derivative of cosine is negative sine. So dy dt is negative cotangent of t. Pre-cal, do you remember what that graph is going to look like? Well, if I squared both sides and added down x squared plus y squared equals cosine squared plus sine squared. What is cosine squared plus sine squared? 1. So what is this graph going to look like? Circle centered at the origin, radius of 1. Okay. And the one on the bottom is going to look like a squished circle, also known as an ellipse. And again, I do not know how things are going to work on the calculator portion for you guys. Mr. Carlos says that first of all, for the multiple choice, you will have access to a Desmos style, or actually Desmos calculator on your Blue Book platform. So be familiar with how to do stuff on that. But you should also be allowed to have your graphing calculator in front of you, and just to show you graphing stuff for these, like if you have your calculator and want to play with it now, hitting the mode button, there's function mode, but the one over is parametrics, and then the one next to that is polar. We don't do sequential in here. That's something else. But now if I hit y equals, the variables up there are all in terms of t. But the thing I wanted to point out, everyone all the way over on the left, if you hit enter once, that turns into a thick line. If you hit enter one more time, it looks like this, and I lovingly call this bunny hop with turd trail, because you can watch it draw, and the reason it's important in parametrics and polars is you see that it's drawing on top of itself. So when it says, you know, so this is a cheat. Gee, how long did it take to do one complete cycle? Well, let's see, it went around twice, and let's look at my window. I told it to go 0 to, that's 4 pi, by the way. So it looked like it went around in just 2 pi. So it's a cheat. You can check to see what's going on with that. Yeah. So can you guys try and graph the second one? Like type in the 3 cosine t, 2 sine t, have it graph from 0 to 4 pi. And I changed the visuals on my window from x and y, -4 to 4. So were you able to get it to do this? No?
I don't get it. I can't like get it to trace it.
Okay. So the way you get it to trace it,
Yeah.
so Amelia, like go all the way to the left. See where it's blinking? And then if you hit enter, right now it would just do the animate and it would not leave a trail. Then it goes to dotted, back to regular. And this one, it's going to draw a thick line. And it's only going to draw it once. You're not going to see that it's drawing on top of itself. But it's still working because you can see the little bubbles here. But you see all the way over. If I hit enter one more time, there's the circle with a dash next to it. And now it's going to animate. And those of you with a TI-84G, it's the thing that says animate. Can everyone get that option? Those of you who've got the calculator out? Anyone else having issues with it? Cole, good? Amelia, is it working now?
What you do?
So for you, go all the way left, hit enter, and then arrow down to line, and then you can choose. All right, anyone else struggling with their, yeah? And really, this is all just a cheat to have things. Okay, are you in degrees?
Use like
There you go. All right, anyone else have an issue? And hopefully we'll have a day where we can just all practice on Desmos on how to do this, since that is probably an easier platform. I don't know how to do some of these things on Desmos though, so we'll learn together, yay. And again, when you get to have your calculator out, I believe you're allowed to use your calculator or the computer. But there are 4 questions that you're gonna have to do without it. Anyway, so that's a quick, how to use your tools. This is what those first 2 parametrics look like. Point of parametrics, they give you a time snap. These were in 0 to 2 pi, that's 0 to 4 pi, like roll tape, where does it go? And for this first one, in 0 to 2 pi, it did 1 circle. In the second one, it did 0 to 2 pi, and then 2 pi to 4 pi, it did 2 cycles around. All right, that's that. I need to show you guys 2 things in 12 minutes. Double derivative of parametrics was a pain in the butt, which is why we did not do it in September. We need to do this now. So Roman reminded us, gee, dy dx is dy dt over dx dt. Perfect, yes. However, if I do the derivative, let's see. Let's just say dy dt was sine t. If I do the derivative of this with respect to time, so if I do the derivative again, is that equal to, don't know how to say it for you. If I do that derivative with respect to time, so basically, derivative of this, is it going to be equal to that? Thinking units wise, is it going to be that? No. Like, normally it's, you know, here's your position with respect to in feet. How is the feet changing per second? Then how is that velocity changing per second again? This is messed up. So if I do this derivative of sine, that's dy dt, sorry, dy dx dt. So why changed twice? But then I now have things not right. So do you agree that we did the change in y with respect to x, and then the change in y with respect to x again with respect to t? Y changed twice, maybe? I want another, well, to get the units right, if I divide by dx dt, I get the change in y twice dx squared. Okay. So the double derivative is this. So take your first derivative, do the derivative with respect to time, and then divide by dx to t again. And it's all just because we need to make the units make sense. Music people, when do you leave, today or tomorrow?
is it d of y over dx, or is it like the d squared, like the second order?
Sorry. So with that, try and find the double derivative of that parametric.
Let's go.
Yeah.
Oh, never mind, I wrote it wrong.
Gross? So sorry, all the stuff in green is supposed to be the numerator. We got a product rule, which I chose over the quotient rule. Adrian? Yeah. So that's really the only catchy thing with parametrics. They'll ask you, hey, what's the double derivative? And they will often, it's multiple choice. That all by itself will be part A, or what, option A. Take the B, take the B. Okay. Okay, I need to show you the other thing with parametrics. Yeah. This is a one-day topic here. The next thing, parametric curve. If we want to find the length of a curve defined parametrically, can we just do Pythagorean theorems? And then maybe integrate from time 1 to time 2? Yep. And quick comment about the binders, I don't generally do problems from there, like, meaning you don't need to bring them in and be like, oh, we're gonna do 2008, number 4. You don't need to be bringing them in. But please return them unwritten in after the EP exam, yeah?
The dt is out of the square root.
Correct. And often these are with calculator. The chapter 10 test that will be next Friday is with calculator. So if nothing else, you need to be able to use your calculator for Friday's test, because I'm not having you use Desmos and your Chromebooks. Okay, you got that? So, we'll try and get through as much of this as possible. The bell will ring soon enough, but, sketching the graph, all right. There's the graph. But how would we do part B? How do we find the highest point? Amelia?
Do the maximum, like you need to do like the double derivative.
Okay, highest point. What gives us an equation of height in any of this? Nathaniel, what do you think?
What's it first derivative?
First derivative of what I have,
dy dx?
dy dt. So what equation makes height? Well, I have this and I have this. Highest height is just y. So checking dy dt, so doing the derivative of y, finding where its critical points are and checking them. Okay, so do that. Anyone get a time? Ray, did you get an answer?
Pi over 2.
Pi over 2. So, is pi over 2 answering the question? The question says, what's the highest point? Okay, he found when, which we need. And just verifying that it's the highest point, all right, we haven't done it in a while. Number line check, if it's free response, so on those longer questions, you'll need to show that you tested it. If it's multiple choice, don't bother. So dy dt changed from positive to negative, so we look at the highest point there. What is the highest point? Well, go back to y itself and plug in. Ooh. Why am I saying that? So the max is 2. Yeah? Points of inflection. How do I, sorry?
Sorry, do we also need to find the x value since that's asking for a point?
Okay, that's what that was, yeah. Then it says highest point. Point usually implies an x and a y value, so. So I'm not sure exactly what it's looking for in this one, but yeah. The x value would be pi squared over 4 minus 5. But Kyle, the next one, how do we find points of inflection? What are those?
When that double derivative switches on.
When the double derivative changes sign. That one's a stinker, okay? See if you can find the double derivative. And then see if I were to change the sign. one does need a calculator. Okay, guys, see you. You people try the homework before you leave, and check the answers in the back of the book.